All right, so this is lab 4 for this course. In this lab, we have a discrete output connected and an analog input connected here for this lab. The analog input, just take you over here, is over on our trainer. We've got this level transmitter here that's going to measure the level in this vessel. And then our discrete output is controlling this solenoid here. What this solenoid does is we have air coming in here, and it's going to switch between these two ports. When the output's energized, air is going to flow out into our valve up top here and allow it to open. When it's de-energized, it's going to plug off this port and it's going to vent the air from this line out and allow the valve to close over here. So that's what's going to happen with our discrete output. Our analog input down here is this pressure transmitter that measures the pressure of the liquid level here in our tank to infer a level for us. So I've already scaled this up and set it up. There's just some zero and span buttons here on the top of the transmitter. I actually just filled the tank to approximately that white tape, zeroed it, and then filled it up to here and spanned it. So it's set up for that, but those two pieces of tape are set up kind of for the approximate 0 and 100% in our tank. So we're measuring the level here with an analog input, and we're controlling the level with this solenoid here that then controls this valve over here. Because if we back out here a little bit more, you can see off the bottom, we're sucking water here through this pump, and it goes up to this valve, which we control with the solenoid, open and close, and then into the vessel here. So in this class, in this lab, we're going to be writing a program to control the level in that vessel. So let's just go back over here and look at the wiring. So discrete output out here to the valve. This is going up to our PLC here. This card right up here, sorry. And the 1756 OB16D module. So looking at this, we have power coming from our 24 volt power supply right here. Flows up. Out here, and I'll probably have a question on what bit number this is, comes out and then flows out on 4-1 up here, which is, if I take you down here on the side of our bench, you can see 4-1 is common to that same spot, and then it comes out and flows up on this red wire all the way up to the positive here for our solenoid. And then the negative of our solenoid flows back and goes in on 4-2. See if we can see that better. 4-2, which is this black lead right here coming back on the solenoid, which then is 4-2 up here, which then comes back down to our negative of our power supply. So whenever the PLC toggles this, it's going to allow power to go out to the solenoid, and whenever it closes, it's going to shut off power. And that's where I wanted to point out this kickback diode that we have here. This kickback diode is to mitigate the inductive kick created by the solenoid. The solenoid is basically an inductor, and when you turn power off to it, it wants to oppose the change in current. And so what it does is it makes a reverse polarity or reverse voltage. It gets really, really high. So what I did is I put a diode here. It's in backwards. You can see that little band there, that gray band, is going to the positive. That means no current will flow here during normal operation. But then when the output shuts off, it'll allow current to flow backwards and it'll dissipate. It'll just be a slight little pulse of current, and it will prevent us from over-ranging the voltage on our PLC and wrecking the discrete output. So that's what that is there for. It's for protection on that. Looking at the analog input now, you can see we start over here. Power runs over to our fuse. I've got this one fused. The reason why I didn't fuse the output is because all these fuses are only rated for about 100 milliamps, and the fuse and the solenoid needs 500, so we'd blow the fuse. So I didn't have a big enough fuse, so for now I left it unfused for this demonstration. But I thought I'd still throw the fuse in for the analog output because it's nice, you can isolate it here. So power comes over, and then on this side here, this flows over and goes out right here on 4-1, but on the plug below. So it flows out, and it's right down here now, 4-1, which then flows out over to the positive on our transmitter, and then comes back on the negative here on the black lead, and then which is this one back over here I've got my finger on right now, and then comes in right here, and then which it flows up to our analog input. And if we look at the wiring diagram on our for analog input card, our 1756 IF8H module, we would see this is wired correctly. So this is the transmitter, the negative of the transmitter coming in, and then we also need to put, since we're using current of 4 to 20 milliamp, we need to put a jumper from these two terminals, and then we run down and over to the negative of our power supply. So if you look at the manual, you could follow all my wiring. Looking at it right now, it's kind of going everywhere, but got it connected up, and I want to show you this working because you're going to be writing the program for this. The program should only take 2 rungs in ladder diagram. So I'm going to turn the pump on, and we're going to see this operate. So it's wired up, and if I just go over here, I'm going to flip on the switch here to our pump, and there you can see the vessel is starting to fill. So in the program, I have it written to shut the valve. Our valve over here should shut when we get to approximately 60% full in our vessel. So the analog input there, so it shut off, and now it's letting it drain. And if we watch over here, we should see our valve open here again at approximately 40%. So those are our 2 trip points: 40% when the level's dropping, and 60% to shut the valve, to stop the level from rising too high. So there you can see, there it goes again, it's going up. You can see how the level kind of overshoots there a little bit before the valve has time to fully shut off. So I'll take you over to the PLC now and just show you the reading that we're getting here, the analog input reading that we're getting here on the tags. So I didn't want to give away my logic here for the program, but I do have the only 2 tags here, the 2 alias tags in my program is LT100 and LV100. So those are the 2 tag names we'll use here, and you can see this is a real data type and this is a Boolean, because this here is just the solenoid, right? So it should just be on off, a 1 or a 0. And then over here, this is our level. So once we hit 60% there, you can hear the valve shut. It kind of overshot a little bit, and now it's going to drop back down. You'll see the energize here, or the LV100 value turn to 1, and it's going to energize the solenoid and raise the level back up. So we're just about to 40%. So there it hit 40, and this turned to 1, and now it's filling the vessel again. So we should be able to write this program. We're going to write this program in both ladder diagram and in function block diagram for this lab. And that is everything you need to know for this part of the lab. One other thing that I wanted to point out that was critical here was that I missed pointing out was this. I had to connect this to the negative of our power supply, this terminal right here. And I'm just going to back out because actually my output wouldn't work properly without this connected. And so this will be something that'll get you to look up in the manual too, what this terminal is. If we count down 1, 2, 3, 4, 5, 6, 7, 8. It's 8 down from the top left here, whatever terminal that would be. It should be an even number, right? So 1, 2, this would be 4, 6, 8, 10, 12, 13. This would be terminal 16 here. So I'm gonna have you look up what that is in the manual. And the other thing that I was going to point out too, I have this 3rd wire that I didn't talk about going out to the transmitter, and I've got this connected over to ground here. And the reason for that is it's to mitigate, we got a twisted pair cable here going out, it's got a shield on it and a drain wire. This is going to drain any interference to ground. That's what that is there for. So I just want to point out those 2 things as well. Those are important to know when we're dealing with PLCs. Proper wiring practices.